Okay, so we'll continue with we saw all the operators, and just to give a glimpse of the operator precedence. Basically, operator precedence comes into play when you have in a single expression you have operators of different type. So what happens is the compiler, the way it generates code, it will make sure the highest precedence operators are first applied, and then it'll keep going down in order. So you can see this table here. So you can see different symbols here. These are all function call symbols, array dereferencing, pointer dereferencing. It's the highest priority. These are also operators. Then you can see some of the post increment, increment, decrement, unary, plus and minus, and so on. Then you see the multiplication, division. Then below that comes addition, subtraction. Then the bitwise shifting. Then comes the relational operators. Within the relationship, there is a gradation, like greater than, less than has higher precedence than the equality, inequality. Then you have the bitwise operators, again AND first, XOR, then OR, then the logical operators. Then you have all the assignment and so on actually. So basically, this is the order in which the operate. If you have an expression without the brackets, parentheses, that's how it will get evaluated. There's something called associativity. This comes into play when you have multiple operands, all of the same priority, same precedence. So then the sequence of evaluation will go from the left to the right. So that is what that associativity does. When you have all operators in the expression or groups or a sub-expression of the same precedence, then the left to right is the most common. So the expression evaluation will go from left to right. So those are the two things. It's good to know this, but I would say in general it's a good practice to not try to remember this and use that behavior. It's better to put the parentheses wherever needed to group things together, so that even for somebody reading the code, even if it doesn't remember this table exactly in sequence, it's very clear what you want to do. So it's always good to group things, whatever you want to do. That immediately forces that sub expression to be evaluated. Then the next step follows. So it's always a good practice to do that. But just to know that there is something called operator precedence in case you encounter some code which is not using the grouping and it's just written with all the operators, without any grouping. Then this will help you to understand what the actual intent of the operation. If you see something like, say, somebody has just written 2 star 5 plus 10, then you should know that this will happen first and then only this will get added, though this facts are not there. So this one is a good programming practice to always put group things that you want to be evaluated first. So, but language supports, most languages have some order of precedence because it has to be deterministic, it cannot be random. So every language specifies something for operator precedence. It is there so that the compiler can generate code in a predictable manner every time. But it's for a programmer, it's good to tell the intent very clearly by grouping things together. The next operator is it's actually called size of. So size of is technically an operator which is actually runs at compile time typically. It is used to get the size of a variable or a type in terms of bytes actually. So you can put size of a variable name or a type name, and it will give you the number of bytes occupied by the variable. For example, if you say I have a variable called long y int x, and I'm saying x equal to size of y, right? So y is a long type. So in this on a modern computer, typically long is 64 bits. So which is actually 8 bytes. 64 bits is 8 bytes. The size of operator will always give the value in terms of bytes actually. Okay. So if you run this code, you will actually see if you have any doubt, for example, you are working on a new system and you don't know what is the size of a particular operand, whether it's 32-bit machine, what it is, if you want to know that, it is good to quickly run that check and you will get an answer. For example, if I declare a variable unsigned int x and I just say printf, I can just directly say this also, printf percentage %d. I can just type size of here itself, size of x. I could assign it to a variable also. I'm just running it directly. If you run this code, you will get to know. So in this machine, wherever the server this is running, an int occupies 4 bytes. Okay, and that's why you're getting the answer 4. Suppose I made it short. Short is typically 16 bits, so you should get 16 bits is 2 bytes, so you'll get 2 bytes. So you can check, for example, if you say double. Double is a double position data type. So let's say double x, it should say 8 bytes actually. Double position is 8 bytes storage. It's 8 bytes. So size of is an operator. This actually compiler, when it compiles itself, it will evaluate this and put the right value there. So basically it's a compile time directive. So it actual value is determined at compile time itself, because compiler is the one which evaluates, it has processed all the things. So if you have a data type of something, it can decide it. Later you'll be studying about other data types like user defined data types like structures and all that. You can also even give, if you have defined a structure and if you want to find how many bytes that structure is occupying, right? You can use that size of to find out on this machine how many bytes the structure is really occupying. It'll be good to know so that you can compute the actual amount of memory you're using. If you're defining an array of structures or whatever, you'll know how much memory you're going to be spending for that. Okay. So this is size of, which is an important, it's good to know that, so you don't make any assumptions about if you are running if you have to develop some code, which is say, for example, independent of the architecture, right? You want that code to behave properly in both, say, 32-bit machine and a 64-bit machine, and you're using some data types which may be varying. If you write code using the size of, you can handle that in the program. Like if the size of returns, for example, say olden days, like old code, maybe 25, 30 years back, int used to be 16 bits, very, very early. At that time, long was 32 those days actually. Then at that time, that code, whatever code was written at the time, if you move it here, some of things may not work properly because things have changed. So, but if you want to write code which takes care of those variations, you can sometimes use size of to decide, how really I have to split the thing, whether it's a 16-bit quantity or a 32-bit quantity. I can decide and then split it accordingly. So size of has many uses like that. It's good to also for us to understand what is the value, what machine we are running in. You can print and you'll get an understanding of that. The final thing about these types and data types is type conversions, right? Okay, so see, there is a lot of things which there is an automatic conversion. When you say automatic conversion, for example, if you have, if you write an expression where there are operands of different types, right? Suppose, let's take an example here. Suppose I have, let's say, I have one variable, say float x, okay? Then I have, say, double y, y1, y2, something like this. And I initialize to some values, let's assume. And I'm saying, say, y2 is equal to x plus y1, right? So for this operator plus, one data is of type float, other data is of type double, okay? So in some scenarios like this, the language automatically will promote the float to a double data type. So these are things called automatic conversions, where the smaller one, if it is possible to straightforward convert to a larger format or a wider means it takes more bytes, right? Double takes 8 bytes, this is 4 bytes. It automatically converts and does the computation. So that is what the statement says. Narrower operand. Narrower means less number of bytes. Okay, it's the width of the word. Or converted to wider one without losing information. Like for example, an integer can be converted to a float. When integer is 4, float is 4, but float has higher precision. So you can convert like that. Int can be converted to a long, 4 bytes to 8 bytes, because you're not losing any data, because a 4 byte quantity can fit into a 8 byte quantity also, right? So those conversions happen automatically. Now, if you try to assign a larger type to a smaller type, you will probably lose value, right? Suppose I have, obvious, right? Suppose I have a long, I'm writing it in Excel as well, it's easy to understand. Suppose I have a long which is 8 bytes, right? I have something big number like this. It's a 64-bit quantity, right? So let's say I have a variable L1, which is this. I have another variable which is a int. I call it, say, I1. If I write something like I1 is equal to L1, okay? Obviously, you're going to lose some information because this needs 8 bytes, whereas in I1, which is of type, say even if I say unsigned int, this is only 4 bytes of storage available. So obviously, you're going to lose something. Typically, when you try this assignment, you will find only the lower 32 bits will be copied. This will be lost. So basically, then the value has no meaning, right? You are getting a very different number. So this huge thing is a very big number. Whereas when you have only 32 bits, this is going to be a much smaller number than what you're going to have actually. So when you try to assign a larger type, which is having more bytes of storage is smaller, you will obviously be using some information, losing information. Depends on the type. See, I might, why I'm saying is, in a long itself, long, if I had only stored a very small number, say like 0x23, I declared a variable as long, but I only stored a small number. When you assign this to I1, you will find it will still print the correct value because upper bits are all 0, so it is becoming insignificant, so it works. But in general, when you copy from a longer to smaller data type, you will lose some value. Think about C. In C in general, many things are allowed. Like it assumes the programmer, the general philosophy in the C language is that it assumes the programmer knows what he's doing. So it doesn't stop you from thinking. Some compilers may give a warning when you do this. There are compilers, older compilers, which will not say anything. So it assumes that you are doing it on purpose for some reason. It won't give a warning. So these are things you have to be aware of in C. Depending on the compiler you choose, the amount of warnings and errors it gives sometimes can be different actually. So that's the thing about type conversion. And these are things, conversions, which by just by assignment or whatever. There is something called type casting where you can explicitly tell the compiler to convert the type, right? For example, and there are again, typecasting itself, there are two types. Like whatever we saw, you can say they are all implicit conversions, where try to assign a larger value, smaller value to a larger value, it automatically promotes. That's an implicit conversion. Sometimes, you may have to do a explicit conversion. For example, look at this example here, right? So I have declared a variable called int, n, a variable of type int, okay? And I want to use a function called square root. Square root is a function, if you give a value, it gives the square root of the value. But the way the square root function is defined, the parameter it expects is of type double. So if you go see the definition of the function, it assumes the parameter is a double parameter. You know double is what? 8 bytes, not just 8 bytes. The way a floating point number is stored is also different from just how an integer is stored. If you take this 8 bytes, right, it will divide into different, there'll be a portion for the mantissa, there'll be a portion for the exponents and so on. So if you directly copy an integer 4 byte integer quantity into the, or even if you have an integer in a long, assume I have an 8 byte long integer, if I just copy, direct copy is will not work, you have to do some conversions. So all those things, or you achieve it by using what is called as casting. So n is an integer value, but I know the function square root expects a double, right? So what I need to do is I have to write something like this. I can say a type name within these brackets and then give the name of the variable. So this will force this n to be converted into a double type, and that is what will be sent to the function. So this may involve some actual logic. It's not like just assignment, right? Because integer is just stored in a very simple fashion. We know how to extract the integer from the bits, whereas a floating point has a mantissa component, exponent component, it's generally stored in some normalized form. If you read the IEEE 754 standard, you'll get a sense. So it has some actual conversion happening. The conversion is done, and that converted value will be sent to the square root function. So these are called type casting, where you can force a type change by using these kind of notation, so that the value is then. Otherwise, if you just send an integer to square root, it won't work properly, because there it is expecting a double data type, it will receive it in a double data type, and this bit format will not match a double data type format. Okay, so this is called typecasting, and it's good to know because many times we may be doing some of these conversions. So where we have to use typecasting, we need to be clear about actually. So in some of these cases, the square root function, the compiler sometimes does it automatically if it sees a definition of square root. For example, in the header file, if square root was properly defined as a function which expects a double, then even if you don't give this casting, right, if you're just given n, the compiler knows that square root expects a double as a parameter, it will do the conversion automatically. But if the header file is not there, the compiler doesn't know, so it will not do the conversion. So in such scenarios where there is no explicit information about the types in the header file, it's safer to put this data type here so that the converted value is passed to the actual function. So this is just one example, but many places you will see you are casting it. And in general, in many places, compiler may give a warning, like if you try to change one type to another type, compiler gives a warning. So to tell the compiler that no, I am doing it on purpose, right? I am doing what I'm really wanting to do. You do the casting so that the compiler now knows, okay, this is being done on purpose. We'll see later when we use things like malloc and all that. There are some pointers called void pointer which can be cast to any type. So we'll see that when we go there. So you can assign it to any type, but you have to put that casting and tell, okay, I'm now treating this pointer as to be of this type. Then the compiler will shut down the warnings actually. Okay, so this is called type casting, which is an important thing in C. It is required to convert values to the right type so that the expected functionality, when you pass parameters and all that, it's kind of matches with what is expected. Okay. So now to summarize this topic, right? So we started with looking at all the data types that are there in C: integer, float, double, character, and so on. Then we looked at how to define variables of different data types. Then we looked at all the operators, which are like arithmetic operators, logical, relational, bitwise manipulation, bitwise and or, then shift operators. So we looked at all the operators, and then we also looked at how to do some basic input output, like printing a message or reading from the keyboard type of operations. And as I mentioned earlier, also this in some embedded systems you may not find it by the same name printf scanf, but they will give you equivalent functions to work with actually. And we saw how implicit type change happens in things like operands, mixed operands, when you have like the smaller operand or the narrower operand will be converted to the wider one automatically. In cases where you need, you can do the explicit typecasting by giving the type name before the variable in brackets, so that forces the type conversion to happen and the right value to be passed.